Okay, this is MAC 1105, section 1.3, models and applications. And in this section, we're going to be looking at how to set up linear equations in order to solve application problems. And also towards the end of the section, we'll be looking at formulas, which are equations that contain several variables, and specifically trying to isolate whatever the variable they direct you to isolate. Okay, so let's begin with application problems, starting off with a review of the 5 steps that you are to use when trying to solve a word problem. Number 1, read the problem carefully several times in order to clarify in your mind how to represent the variable expressions that stand for the words in the problem. And then you'll want to read it again to look for the sentence that tells you how to set up the equation. You'll also want to read it again when you try to check your final solution. So we're going to follow the steps pretty much in this order. Reading the problem, developing expressions that represent the words and the unknown quantities in the problem, then combining those quantities to set up an equation, which we will then solve, and then we'll check our solutions in the original wording of the problem. Okay, so your first scenario concerns various activities that people spend throughout their lifetime, and they talk about in this diagram the activity of sleeping, working, watching TV, doing housework, etc. And you can see how this is labeled. Number of years the average number of years that you spend doing that activity during your lifetime. And we're going to use these specific words in order to set up this problem. So just to get us familiarized, and as you're reading these problems, I would suggest that you have some kind of highlighter or way of pinpointing or bringing to your attention certain expressions in the problem, just so you can be clear on how to label your unknowns. So it says, according to the American Bureau of Labor Statistics, you will devote 37 years to sleeping and watching TV. So even though a couple of the words that I'm going to say right now aren't in this sentence, it's pretty much indicated that you're going to devote a total of 37 years to sleeping and watching TV combined. They have selected those 2 activities from the diagram above, and we're concentrating on just those 2 activities and the number of years that you spend on those 2 activities. It says the number of years, another thing that you're going to want to try and pay attention to as you go through these word problems is, the skill of being able to pick out what is the more simplistic quantity or the smaller quantity, because that is the one that will get represented with just plain X, whereas the more complicated quantity, typically the larger one, will get built upon that X expression. So you really want to pay attention to trying to identify what that simplistic expression is or the smaller quantity. The number of years that you spend sleeping will exceed. That's a key word right there that tells you sleeping. You're spending more time. It is the bigger quantity than you are spending watching TV. I would highlight at this point just so that you understand that there are 2 things that you're going to label here. Number of years spent sleeping, and you're also going to have a label that talks about the number of years watching TV. So as we go to set up our expressions, I've already identified that you are spending more time sleeping than you are watching TV, and that these are our 2 titles. Let's move to the next page and begin to set up those expressions and the equation. Okay, so on the next page, just kind of guiding you through these problem-based scenarios. What is the smaller quantity? Years spent sleeping or years spent watching TV? The smaller quantity should be represented by X, and the larger one should be represented or built using that X. So we've already, discussed that on the previous page, that you're going to spend more time sleeping. That's why they used the word exceed when they described it, than you are watching TV. So this is the smaller amount of years spent on watching TV. You are spending 19 more years, and it said it in this way. It said number of years spent sleeping exceeds the number of years watching TV by 19. Okay, so these are your two expressions that represent the two unknowns that they are trying to get you to solve for. They want to know, how many years do you spend sleeping? Right now, it's just an unknown represented by this expression. How many years do you spend watching TV? It also mentions on the previous page, and you can go back and read it again, that combined, that these two activities, and I extracted that for you right here, states that when the years on each activity are combined, the result is 37. So we're going to take number of years spent watching TV plus number of years spent sleeping combines to 37. And then you can even clean it up a little bit, like you can combine these like terms and then continue with this equation until you solve it. So I'll do that here. You're going to use inverse operations, of course, when you solve your equations. Like the first thing that I would do is subtract 19 from each side. That would leave you with 2x. You can put that in your calculator. It will be 18. One more inverse operation, which is to divide off that multiplier. And that will lead you into x is equal to 9. This is where it comes in handy, the labels that you created earlier in the problem. Otherwise, you don't know whether the 9 stands for years spent watching TV or years spent sleeping. So those labels are important. Students typically have the issue of getting their answers mixed up and reversing them, which causes you to lose points. So let's make sure you get organized and use those labels. So let's come back up here. What does X stand for? And then we'll know what this 9 is. It stands for the years watching TV. Okay, so we found that. Now, if we truly use the wording in the original problem, it was talking about how combined TV, number of years watching TV and number of years spent sleeping combined to be 37. So if you know they combined to be 37, and this is already 9 of them, I would just subtract the 9 and you would get 28. 28 years left over, and that's the number of years spent sleeping. Now, is this correct? Well, in the original wording of the problem, they said the number of years you spent sleeping would exceed the number of years watching TV by 19. Is this 19 bigger than this? It is. 9 plus 19 is equal to 28. So you are checking your solution in the original wording of the problem. This plus 19 would give you this, so it all checks out. Okay, a problem that is similar to that one, where again, you're reading it repeatedly. You're trying to figure out what is the smaller quantity and representing it by X, then building the more complicated quantity or the larger quantity using that X expression, and then combining them in some form or fashion. You will use the wording in the problem to figure out, how do I combine them? Should I add them? Should I subtract them? Should I multiply them? The wording of the problem will tell you in what manner you will combine your variable expressions to get some value. Sometimes they'll tell you they'll make an indication to set them equal. Any of that wording can be used, which is why we need to read these problems several times to pick up on that. Okay, so first time through, let's just get ourselves familiar, possibly highlighting the things that stick out. It appears that we are talking about salaries here. One person has a master's degree, and they start talking about how to represent that master's degree as an expression. They say that the master's degree is 70,000 less than twice that of a bachelor's degree. Okay, so they're giving you information. They're talking about a master's degree and a bachelor's degree. Now, perhaps in this problem, you get confused about which one's bigger and which one's smaller, but I think that we can all agree that the master's degree, typically you're making more with the master's degree than you are with the bachelor's degree. So we would be labeling, we would go for two labelings, master's and bachelor's. The bachelor's is going to be the smaller quantity and therefore would be represented by X. And then we will build on that X to try and represent what these words say right here about the master's degree, that the master's degree would be 70,000 less than twice that of this. Twice the bachelor's degree would be 2X, and then 70,000 would be subtracted from that. So let's go to the next page where we are representing everything. So bachelor's degree, the smaller quantity, we'll just call that X. And then the master's degree, it said that it was 70,000 less than. That means take 70,000 off twice the bachelor's degree. Twice the bachelor's degree means double the bachelor's degree. Then subtract 70,000 from that to make it 70,000 less than just doubling it. Write an equation that models the verbal conditions. I've extracted the sentence that talks about how to combine these two salaries that they gave you in the word problem. It says when the salaries are combined, the result is 173,000. So we're going to take our bachelor's salary, combine it with our master's degree salary, and combined, that is means equal to 173,000. Solve the equation. As you solve the equation, I'll just clean it up a little bit right here. I'll at least combine these, and then we'll start going through the steps for isolating X in the next step. So there's 3X minus 70,000. I'm going to leave the commas out and the dollar signs for right now. I have to squeeze this in here. Is equal to 173,000. And then we'll start with that right here. Okay, so 3X minus 70,000 is equal to 173,000. Now let's start trying to isolate the X term by performing inverse operations. I'm going to add 70,000 to get rid of the negative 70,000, and likewise on the other side. Okay, that'll lead me into 3X is equal to, and you can put this in your calculator, so that'll be 173,000 plus 70,000. And that gives you 243,000. And then go in for solving for X by removing this multiplier by using the inverse operation, which is division. So that gets rid of this, bringing us into X is equal to 243,000 divided by 3, and we have 81,000. Again, at this point, very helpful to know what X stands for, so you don't deliver it as an answer that it really doesn't stand for. So coming back to our labelings right here, bachelor's degree is the X value that we find. So this is the 81,000. And then from the wording of the problem, they said that the master's degree would just be twice that amount minus 70,000. So we can also put that into the calculator. So let's see. So twice the bachelor's amount, which was 81,000, but 70,000 less than that, which would be There's 2 times 81,000, 162,000 minus 70,000. And the answer to that is 9.